Hello and greetings from percentilers and welcome to Quant Question of the Day. Let's see today's question. Hardcore mixture question. Please pause the video. Try to solve the question. This is comparatively more difficult question than the other questions that we have been. All right. Again, although the question can be solved using options, you can see out of all the options, it is difficult to decide in the first place which option to try with. However, I've if I were to try with options, I would have tried with the fourth option, which is 3 kg, because in the first place they are mixing certain weight which is supposed to be found. This is the question with 3 kg of pure silver. It would have given me quite an ease of calculation. Okay, but anyway, I'm not solving this by options. I'm going to try the alligation method, most competitive and perhaps the fastest method to solve this question. So there are two unknowns. The percentage of silver, let's call it X percent, and the weight, let's call it W. So we would need two equations. Let's use alligation to see how we would be able to make two equations. So the first case, when this X percent of silver was mixed with 100% silver, we got 90%. This gives us 10. This would give us 90 minus X. Okay. We know that the weight of this was W kg and this was 3 kg. So we can translate this finding into making an equation that W by 3 is equal to 10 over 90 minus X. In the second situation, the same X percent mixed with 90% and we got 84%. This gives us 6, this gives us 84 minus X, and actually this is again W kg and 2 kg. We can translate the following equation. So W by 2 would be equal to 6 over 84 minus X. If I call this equation 1 and this equation 2 and I divide equation 1 by equation 2, I would get 2 by 3 equal to 5 by 3. It's 84 minus X upon 90 minus. Solving this equation, we could find X as 80. So we get the percentage of silver in the original alloy. However, this was not the question. The question was about W. So you can put this value of X in any of these two equations. Suppose you put X over here. So you get the value of W as 3 kgs. So this is how we will find the answer to this question using equations and alligation. And also now you could see that my idea of trying out an easier number first was actually good. People who would not actually be able to imagine doing so much so in this question could have gotten lucky just by this understanding, just by this observation that initially 3 kg is being mixed with the initial alloy. So let's take the value 3 and check. If even if they know the basic understanding of average and mixture, they would still get the confirmation that this was the right option. So good numbers are often the answer.